Our launcher gives you access to specialized labs, from classification and regression to dimensionality reduction, and even specialized auto model. Today, I'm going to walk you through Visual ML Studio, an all in one neural networks lab designed to bridge the gap between complex code and intuitive experimentation. Let's look at the control center on the left. The workflow follows a logical path: task, data, model, and control. First, task selection. First, we define our objective. Are we predicting categories, classification, or continuous values? Regression? Today, we're sticking with classification. Second, dataset management. We've integrated built-in datasets like the classic iris and digits dataset for teaching. However, for power users, the Upload CSV feature allows you to drop in your own proprietary data. Notice the error handling here. The system alerts you to file size limits and upload status immediately. Third, data summary. Once the data is loaded, the Data Summary tab gives us an instant look at class balance. In our Iris example, we see a perfectly balanced 33% split across 3 classes. Knowing your data balance is the first step to a successful model. Now, let's configure the brain of our operation. Under the model section, we're using a feed-forward neural network. This is where the lab aspect truly shines. You have granular control over the hyperparameters. N underscore layers. You can adjust the depth of the network. Units control the width of each hidden layer. More units can capture more complexity, but watch out for overfitting. Activation functions. You can toggle between RealU, 10H, or sigmoid. For this demo, we'll compare how changing from RealU to sigmoid impacts our training speed and accuracy. Learning rate and batch size. Essential for controlling how fast the brain learns from its mistakes. The beauty of Visual ML Studio is that you aren't writing lines of Keras or PyTorch. You are manipulating the architecture and seeing the results instantly. Once we hit run experiment, the engine goes to work. Within seconds, we are presented with a comprehensive results dashboard. Look at these 5 key metrics: train, val, and test accuracy, alongside train and val loss. Why 3 accuracies? We use the train set to learn, the validation set to tune, and the test set to provide an unbiased final grade. The loss curves. Notice in this run, our validation accuracy orange line actually ended higher than our training accuracy, suggesting a very robust, well-generalized model. To truly understand why the model made its choices, we provide 2 high-level visualizations. First, decision boundary, PCA 2D. Since we can't see in 4 dimensions, we use principal component analysis to flatten the data into a 2D plane. You can literally see the colored zones where the model decides a flower belongs to a specific species. Second, the confusion matrix. This is the ultimate truth teller. It shows us exactly where the model got confused. For instance, in this run, it correctly identified all of class 0, but swapped a few instances between class 1 and 2. This tells us we might need more units in layer 2, or perhaps more epochs. Third, a good scientist keeps a log. Every time you change a hyperparameter and click run, the experiment log at the bottom records the configuration and the outcome. You can compare run, F, RealU directly against run, sigmoid, to see which performed better. 4. Finally, your work isn't trapped in the browser. You can export to CSV or Excel for your research papers, or download a PNG zip file of all these beautiful visualizations for your final presentation. Visual ML Studio isn't just a tool. It's a sandbox for the next generation of AI innovators. It makes the complex simple and the invisible visible. Start your first experiment today. Visit Visual ML Studio for more learning